谢谢一位的分享。接下来我们要连线远在美国的Mashiat，他是来自 Risc0 的，他跟我们分享主题是 Risc0 的 zkVM 和 Ecosystem，所以大家稍等一下，我们连线一下。Hi Mashiat, can you say hi to our audience? Thank you so much for joining us. 那个
Hi everyone.
Okay, thank you so much for the time, guys. You can take the lead.
Yeah, of course. Let me share my screen so I can get my presentation started. How's it going, Hong Kong?
It's
the first time.
We're in Shenzhen, but it's okay.
You're in Shenzhen. I'm so sorry.
No worries.
Wow,
Yes,
amazing.
Very close to
I've actually been to Shenzhen when I was like 13 years old, like almost, oh my God, 15, 16 years ago. It's been one of my most favorite places ever. I'd love to come back.
Please, and we hopefully to see you again next time in Shenzhen with our 4 years, 5 years anniversary.
Amazing. Yes. Well, thank you everyone. It's so great to meet you. I'm really excited. If you don't know, I'm wearing my Risc0 shirt repping our team. And I'm really excited to give an introduction to Risc0 and what we do. We are a team that is dedicated to bringing universal zero knowledge. And yeah, I want to take you through our technology and our ecosystem. So for our agenda for my talk, I'm going to be chatting about a little introduction, who I am and our team, the Risc0 zkVM, how it works, and why we've made certain design choices. Bonsai, our remote proving service, and then we will kind of dive into some of the use cases, our ecosystem, and then resources that you can tap into after this presentation and after this talk. Awesome. So hi everyone, my name is Mosh. This is short for Mashiat, that is my full name. I work in partnerships and ecosystems for Risc0. I'm currently based in Chicago. I'm in the US, so if you are ever here, please let me know. The summers in Chicago are absolutely lovely. I've been in the crypto space for almost 9 years, and I'm very excited about zk accessibility and creating systems and platforms that enable people to own their own data. I believe data ownership is very, very important, especially in this day and age where we are always selling our data, but we do not have ownership of it. So previous to Risc0, I was working at Celo. I don't know if many of you have heard about it. Celo was an alternative layer 1 blockchain. And so I was very much focused on DeFi and NFTs for emerging markets such as Africa, India, Southeast Asia. And before that, I was working at Blockchain at Berkeley, and I also co-founded Chee 256, which is a governance community. And they mainly do a lot of governance, protocol governance for Uniswap and other big ecosystems. So outside of zk, I'm still very much active in the emerging market space. I'm a co-founder at Oasis On-Chain, so we do a lot of consumer crypto for the Global South. We are hosting our next summit in the Bahamas in January 2025. So if anyone wants to come to that one, please DM me, and I will, of course, send you all of the details for that. So let's get started into Risc0. What is Risc0? So our company started in 2021 to really tackle the biggest challenge in our industry and potentially our society, which is, increased centralization of data and the increased centralization of not just applications that we use, but also the infrastructure that we use to build these applications. Our biggest purpose is really to be this bridge that brings general purpose computing to zk. So we want to empower users to trust programs that are run anywhere, while giving developers really easy access tools that they already know and love to deploy zero-knowledge applications. Our mission is essentially, how can we help developers accelerate ZK innovation and develop zero-knowledge applications, or ZK dApps, in weeks instead of months. And our team is a passionate group of 40 people. We are, cryptographers with PhDs who have been with the problem their whole lives, white hat hackers, futurists, nerds, and optimists like me. So before I dive into, what Risc0 is and like what our zkVM looks like, I wanted to give an introduction to general purpose zkVMs. So in, the zkEVM, I'm sure many of you have heard of. It's a virtual machine that essentially executes Ethereum smart contracts in a way that's compatible with zero-knowledge computation. And essentially, zkEVMs, they compress a large number of Ethereum transactions into one single low-cost, succinct validity proof. But at the time when zkEVMs were forming, the Ethereum virtual machine, or the EVM, was not best designed to run a ZK circuit within it. And that's why a lot of zkEVMs in the market have had to make significant trade-offs, from choosing to not be the most Ethereum equivalent, to having discrepancies or lots of differences between gas costs and proof of costs. So essentially what it means is that building a zkEVM on Ethereum has a lot of limitations, and it actually makes it very difficult to implement and optimize validity proofs. And that's why, we've seen this rise of the zkVM, which is the zero-knowledge virtual machine. And what the zkVM does is that it essentially is a virtual machine that emulates for a ZK proof system. And it essentially guarantees secure and verifiable, trustworthiness through the ZK proofs that it generates. So in a zkEVM, you would be proving the execution of a specific program. With a zkVM, you're proving the execution of the VM itself, or the virtual machine itself. So we've seen different types of, zkVMs kind of come into the play. You have teams like Alio or zkSync who are building Noir, and essentially they're kind of building a middle ground language that goes into a compiler. It generates like an arithmetic circuit, and then you take in inputs, and that arithmetic circuit generates like a proof. But sometimes what you want to do is essentially abstract that a little bit more and create like more of a VM architecture. So in this case, what you would be doing is you would take a program, push it that your compiler would understand, push it through your compiler, and what that would do is that it compiles into a set of instructions, or ISA. And what that means is that now your program is also an input into your VM circuit. So in the VM architecture, your VM circuit not only takes in the inputs like the direct circuit would take in, the direct arithmetic circuit, but you're also taking in the original program that is written in a language that the compiler can understand. And the benefit of this is that now you are opening up the playing field to more mature ecosystems, and you're opening up the playing field to more accessible languages, rather than having developers, really learn a very niche language, such as Noir or Leo. So entering the Risc0 zkVM. What are the problems that we are solving? Within Risc0, some of the key things that we've noticed are the current challenges that developers face in this Web3 and on-chain world. So first of all, as I mentioned, even within the direct circuit design, there's a lot of developer friction. As a developer, you will have to learn a new programming language such as Noir, Leo, Snarky.js, adapt your program and your inputs to blockchain-specific, design patterns. And essentially that can impact your lead time and go-to-market time to building your application and make it more complex and time-consuming. Not only that, building on chain is pretty difficult. There's a lot of scalability limitations, even with traditional like on-chain execution, especially when you're executing on the base layer, such as Ethereum, there's a lot of network congestion and really high transaction costs. And we've also noticed that as developers are trying to build more complex applications, there's limited expressivity. So this means that there's a lot of gas limitations, cycle count restrictions, and what that can do is actually impact how complex you can build your Dapp and how functional you can make your Dapp. It also limits interoperability and cross-communication between applications as well. So we try to solve all of this with our Risc0 zkVM. We're not 100% perfect, but we're really getting there. So what is the Risc0 zkVM? The Risc0 zkVM follows the VM architecture, which is more of that architecture that takes in the program into a language that our compiler can understand, generates a set of instructions, and then that goes into the VM circuit with our additional inputs. And within the Risc0 zkVM, we've chosen to have Risc5 open source microarchitecture. So we have kind of implemented an open source architecture that everyone can easily access. And the benefits of having a Risc5 microprocessor, like as part of our circuit, is that instead of writing your own DSL or writing your own compiler, you can actually use any sort of language that the LLVM supports. Right now, we're just really focused on Rust because it has a very mature ecosystem, lots of folks know it, and we can actually provide the best developer experience for teams that are writing their programs in Rust. The key properties about our Risc0 zkVM are the three. So first of all, it's a virtual machine, which means that it essentially emulates a physical Risc5 circuit, and so it runs code like a physical Risc5 circuit. The second thing is that it's verifiable. So this means that the zkVM, after it takes in the guest program and program inputs, it generates a receipt that tells anyone that the code that went into our zkVM was executed in a cryptographic manner. And thirdly, it's zero knowledge. What that means is anything beyond the program and the program inputs isn't published. And so essentially all of the data that is going in is private data, and that's what makes it zero knowledge. So I'm going to take you at a very high level how proving works within our zkVM. So what we have is that we have the guest, and the guest is essentially like a program that is running on the zkVM, and the host is the system that the zkVM is running on. And what we have is the host emulates the guest, and it tells the guest to execute, a particular program. In this case, the host will send the guest, private data. The guest will execute code within that program, and it will construct a receipt. The receipt is then returned to the host as the proof of compute. And later on, the host can decide to put this receipt, on chain so that it can be publicly verified, or it can keep the receipt and do whatever it wants. What's important about this receipt is that the receipt actually provides evidence for the valid execution of the guest program. So it actually tells us which part of the code in the program was executed and what was the result of that computation. There are two parts within this receipt. So the first one is a journal, and this contains all of the public outputs of the guest. And the second one is the seal. So this is also contained within the receipt. And the seal contains like more cryptographic information instead of like just public outputs. So it'll contain a ZK snark proof of the guest program's correctness. It's generated by the prover. It also contains a hash of the guest program. And so when you have a receipt, when the host receives the receipt and puts it up on chain, what that means is that anyone, you, me, Bob, Alice, can go and publicly verify this receipt, and they will take a look at both the journal, and they'll be able to see like what were the public outputs of the program and of the computation, but they will also be able to see that, okay, well, this is the program that was, or this is the hash of the program that was correctly executed. As I mentioned, within the seal, we have the ZK snark proof. What we do is that we also take that snark proof and we wrap it in Grot16 to reduce the size of the proof and to ensure these applications of ZK can be as scalable and as efficient for our partners. So now we beg the question, why use Risc0 zkVM? So in the problem slide or the current challenges slide, we really mentioned that, hey, there's a lot of developer friction that is going on because developers have to learn a whole new language many times, and they have to navigate a lot of specific blockchain designs, which slows down the go-to-market. There's a lot of limited expressivity because of gas limitations. And this can actually, and high gas costs, and this can actually limit like complexity of the dApps that are being deployed. And there's a lot of high gas costs and transaction costs from building an on-chain application. So this is how we, through our zkVM, abstract away all of these challenges. With the Risc0 zkVM, we are essentially helping developers focus on building applications instead of building circuits. So all you need to do is run Rust code through the guest and through the VM, and you can prove the execution of that code directly. What makes our zkVM very different from other zkVMs in the market is actually a new innovation that is called continuations. And continuations is a technique that we use where we will take a proof request for a guest program or for code within a guest program, and we will essentially split that request into small segments. And after that, we will independently prove each segment in a parallel fashion. So what we're doing is that we are essentially keeping the memory size constant, but we're able to prove very large computations very, very quickly. And what this does is that it actually unlocks boundless, unlimited computations, and we're able to generate, proofs of millions and billions of cycles in a matter of seconds to minutes. The other feature that makes us very different from VMs and provers in the market is proof composition. Essentially, what we want to do is that we want to make it as cheap as possible to generate proofs and as cheap and efficient as possible to verify proofs. So proof composition is a technique that we do in where we aggregate as many proofs as possible into one batch, and that generates one single receipt. That single receipt is then posted on chain, and any public verifier or public entity just has to verify that one single receipt to verify that the data across all of the other proofs are valid. And lastly, our zkVM, it's fully open source, and we actually encourage folks to install it locally into their machine so that you can generate proofs of your own private data using your local zkVM only on your machine. You own your data. We just provide, the software for you to run it. And all of the underlying thing is that we want to help developers who are building ZK applications get to market fast. On average, teams that are using Risc0 zkVM are experiencing up to 1,000 times faster development time. We have very stable APIs. As a team, we've been building for the past 2.5 years. And what this means is that we've achieved a level of maturity where developers can essentially build complex applications with the peace of mind that as they deploy new features or as we deploy new upgrades to our zkVM system, things aren't going to break. We have just released a new version of our zkVM, which I will talk about a little bit more later. And what makes this extremely compelling is that we have new performance benchmarks that are coming very, very soon, basically on Monday next week. And these benchmarks essentially place us as one of the most performant and cost-efficient zkVMs in the space. And thirdly, our zkVMs, just like our zkVM solution, just like zkEVMs, obviously enable validity proofs and zk fraud proofs at the protocol level, but they also enable zk at the application level. So we really want to be the solution for the entire stack. And we have a feature called Steal, which is a view call library. And what that does is that it really enables developers to build complex Rust applications for Ethereum by bypassing the size and the gas limits. With Steal, you can essentially read and compute over Ethereum's historical state through these secure view calls. And essentially what these are storage proofs. And you can not only be able to access these storage proofs, but then you can program different types of zk computation or arithmetic within our zkVM on them. So essentially what you have is programmable storage proofs, which is very, very powerful. And it also allows application developers to achieve more interoperability, because now you can essentially deploy your apps once they're written in Rust to any of our supported chains. And we have our verifier on, I believe, 8+ different chains, both in the Optimism ecosystem and the non-optimistic rollup ecosystem. And essentially our verifier can then verify any of the proofs that your application is generating on any of the chains that you've chosen to deploy on. So what we're really trying to enable is that all you have to do is essentially run your program once, and then you can verify it everywhere and achieve some level of Dapp interoperability, while also bypassing a lot of the gas limits and size limits that just building straight on top of Ethereum or straight on chain has. So the Steal view call library is extremely powerful. I really encourage any application developers here to test it out. It is just a great way to understand the value proposition of our zkVM, but it will also help you 10x your development time and go to market for your application. And we have a very exciting news. So our zkVM 1.0, which is our latest version and the most stable version of our zkVM, is now live. This is the world's first and most performant production-ready zero-knowledge virtual machine. We have very, very strong benchmarks coming out on Monday, and I would love to invite the community here to also participate in reproducing these benchmarks and showcasing them off. We will be posting our guide very, very soon, so you will have a chance to test out, zkVM 1.0 and play around with it and tell us how it works and give us a lot of good feedback. So next up is Bonsai. So we've spoken a little bit about the zkVM, and this is, a system that you can run locally on your machine, on your hardware, on your laptop to generate zk proofs. But what if you don't want to do that? What if you are a really big team and you have a lot of users and there is a lot of proof requests that are being generated? Well, not to worry. We have a remote proving service, Bonsai, that is essentially used for that, for very large computations. So Bonsai is a remote proving service. It is highly, highly parallelized, and it's very performant. You want to use Bonsai when you really want high performance proof generation for your application, but you don't want to run the zkVM on your machine. You don't want to manage any hardware. So you just want to offload it to us. And the way it works is that you have to just specify which zkVM application you want to run and the inputs to the guest program. Bonsai will then take that proof, like the proving request or the proving work, and it will split that work across a parallelized cluster of GPUs that we run on the back end. What this does is that we can essentially return you a proof, return you a very highly performant proof in a very short time. So use cases leveraging Risc0. At Risc0, we're really known for general purpose ZK, and that kind of means that we can do everything. As I mentioned, just like ZK EVMs, we support a lot of different rollups, both optimistic rollups and also, ZK rollups in generating proofs for the Ethereum blocks. So Zeth is our type 0 ZK EVM, and this is a solution that actually uses Bonsai, and it generates, proofs of validity proofs of Ethereum blocks in minutes. This is one of the fastest solutions that is out there, and we have received a grant from Optimism to complete this solution and have just passed acceptance testing. There are a lot of teams that are both, OP stack, or they are non-EVM, such as, in the Move ecosystem, or they're in the Cosmos ecosystem, that are optimistic rollups, and they're looking to essentially have zero-knowledge fraud proofs. So they will use our stack to generate, ZK proofs of their fraud proofs or of their blocks. And we essentially help them create a pathway to becoming a full-on validity rollup. And that's kind of our goal with supporting rollups, with our zkVM supporting rollups. The second use case that we are seeing is more at the application layer. We do a lot of work with authentication teams and wallet providers or identity teams. We actually have 2 demos on our website at risc0.com that I think are very, very informative of how ZK proofs can be used to generate a proof of like digital identifiers or decentralized identifiers, and then essentially give the user access to a microservice. So Bonsai Pay and zkKYC underlying, it's the same kind of architecture. We are generating, a ZK proof of a JWT token or an authentication token that is either issued by a KYC provider or it can be issued by email providers such as Google Login. And then later on, because the ZK proof is publicly verifiable, the user would just hit verify and then get access to, whether it's funds that they're claiming or to an application that they want access to. We're also seeing a lot of use cases within gaming. We have 2 gaming teams that are building with our stack. And essentially, on-chain gaming is super expensive. I think for every on-chain move, it takes around 2 million gas to verify that move. Or to verify a proof of that move. So what they're doing is that they're offloading computation of multiple on-chain moves into our zkVM, using our proof aggregation feature, aggregating the proofs of all of those moves, and then posting a single proof on chain. And with Risc0, verification is very, very cheap. So in general, it costs only 300,000 gas instead of 2 million gas to verify a single proof using the Risc0 verifier. And lastly, we are also seeing a lot of headway in governance. On-chain voting can be very, very expensive. And so we enable a way to process a lot of ballots in the on-chain governance process into the zkVM so that it is affordable for users and token holders or governance members to participate in an efficient way. So our ecosystem is very much growing. We have over 40 plus teams building multiple different use cases within the Risc0 ecosystem. As I mentioned, we have a lot of gaming teams. We have a few authentication teams, folks that are not only building ZK logins, but they're also building ZK passports. So these are all the solutions that we're very excited about. A lot of our teams that we're working with are also using Risc0 to generate zero knowledge proofs of blocks in their own rollups. These are rollups that are optimistic rollups that settle on Ethereum, or optimistic rollups in other ecosystems that are non-EVM compatible. And we also work closely with a lot of ZK ecosystems as well, just because they support our verifier. And we're also able to bring, through our VM, we're able to bring more Rust accessibility to their developers as well. So developers can essentially first put in a Rust guest code into our zkVM, and then they can transition their way into learning a more complex language for that ZK rollup ecosystem. So yeah, if you are working within any of these fields, whether it's rollups, gaming, identity, DPIN, which is more physical infrastructure such as trusted execution environments or TLS Notary, please come to me. I'm very, very happy to chat and give you partnership support or integration support. We have a full team of solution engineers and a very hands-on product and engineering team if you are more further along in your stack and you need more deeper help into integrating Risc0 as part of your solution. Lastly, I'd love to see all of you at EthCC Brussels. I don't know how many of you are going, but we are hosting our own half-day conference on July 8th. It will be called Boundless, and we will be featuring a lot of our partners and teams across the zero knowledge, but also beyond zero knowledge in the roll-ups, gaming, identity, and hardware space. And the Luma for RSVPing to Boundless is here. I will of course share these slides with everyone so you can take a look. Please follow us on Twitter at Risc0. And I have a few links that I think would be very, very helpful for people to get started. As I mentioned, zkVM 1.0 is live. And we have a quick start guide if you ever want to test out our latest solution. We'll be releasing our benchmarks very, very soon on Monday, but I would love to invite the community at Dapp Learning to also join in testing out zkVM 1.0 and running your own benchmarks. Your feedback would be absolutely valuable to us because we are currently very much iterating. And I'm happy to connect you to our developer relations team who can support you in setting up and installing zkVM 1.0 locally onto your laptops. Second, if you want to try out Bonsai, which is our remote proving service, and you don't want to run the ZK virtual machine on your local hardware, please request a Bonsai API key. This is a simple Google form. I'm usually the one who approves this API key, so I'll be able to approve all of you here. And you get 25 billion cycles as a quote to work with initially, which is a lot of cycles. And it's a great, easy way to get started with writing your own Rust guest program and then testing out how our remote proving service works, what is kind of the proving time and the proving costs that you are experiencing through your requests. It gives us a lot of information as well on how to fine-tune Bonsai and how many clusters of GPUs to use and to service. And thirdly, I would love to encourage everyone to learn more about Steel. This is our ZK coprocessor solution. It essentially is our view call library that enables these programmable storage proofs and allows application developers to write applications in Rust and deploy them on any chain that they want. We usually support almost all EVM optimistic chains and also some of the ZK chains such as ZK Sync and Starkware. So if you choose to deploy your application on there and generate use our zkVM to generate Risc0 proofs, your proofs will be easily publicly verifiable. And we kind of take care of that. So yeah, let me know how you find steel. We're always looking for more application developers who want to use more of a coprocessor solution. And that's about it. So thank you so much. I don't know if I have time for questions, but I will pause there because I know I went through it very quickly.
Thank you so much. I think that we will collect questions from the audience and send back to you later on. And
that sounds great.
Okay, thank you for your time. Bye.
Bye.